Is U with x, y, z elements from R³ given by x minus 2y plus z equals 0 a subspace of V equals R³? So, our familiar vector space, I'll also add it to the playlist. Do you have many more practice videos on this? 3 conditions must be met. First, that the 0 vector is an element of U. Second, the closure under addition. In other words, if U is an element of U and V, of course a vector is also an element of U, then U plus V should also be a vector element of U. And third, the closure under scalar multiplication. If U is a vector element of U and K is an element of R, then necessarily K times U must also be a vector element of U. Let's start. First, the 0 vector element is in U. We are given x minus 2, y plus z equals 0. We substitute accordingly. 0, 1, 0, minus 2 times 0, plus 0 equals 0. We can already see that this is correct. The first condition is satisfied. Secondly, of course, you could write all of this in more detail. Secondly, what matters to me here is the principle. We have a U vector, U1, U2, U3, which is an element of U. In other words, it follows that we have U1 minus 2 times U2 plus U3 equals 0, where U is used for x, y, and z respectively. We have V1, V2, yes, I used V, V3, so V1 minus V2 plus V3 equals 0. Now let's look at addition, so another vector. I'll say now, for example, W equals then U1 plus V1, U2 plus V2, U3 plus V3. Accordingly, if we add here U1 plus V1, we would have as the first coordinate U1 plus V1, then V1, then minus 2, U2 minus 2 dot V2, and U3 plus V3. And if we were to write all of this side by side and sort it, we would have accordingly U2 minus 2, U2, U3, yes, and there we can see that U1 minus 2, U2 plus U3, yes, again here. Accordingly, that results in 0, and V1 minus V2 plus V3, that's this here. And then we have, again, 0 plus 0 equals 0. The second condition is also fulfilled. The third one, with the scalar multiplication, we have U again. It would be U1, U2, U3. So accordingly, U1 minus 2, U2 plus U3 equals 0. We multiply the whole thing by k, so then k times the U vector equals k times U1, k times U2, k times U3. And we would have, if we have this vector accordingly and have used it here, then we have accordingly. K times U1, we have k times minus 2. U2, we have k times U3, we yes. And if we grab the whole thing again now, multiply out k, then we actually get k times U1 minus 2, U2 plus U3 again. And there we see again, the whole thing here is again equal to 0. And then we have k times. That's supposed to be a k times 0 equals 0. And the third condition is also fulfilled accordingly. That was another example of that. Proving a subspace. Many more practice exercises in the corresponding playlist. Then it's once again, math vocabulary recognized, danger averted.